Hello, everyone. Thank you for joining one of these personal injury uh, webinars at Hawkins today. And I'd just like to briefly start just saying that with hand-arm vibration syndrome, or HAVS, for the intended audience, we'll be looking at the basics of HAVS because it's important to have a good overall view of how things work. Um, Hello again to everyone, and thank you for joining. My name is Andrew Peplow, and I'm part of the acoustics group here at Hawkins and Associates. And I've been working in this field for noise and vibration for over 30 years now, and I've had the privilege of working with some great colleagues in academia and engineering and consultancy across the UK, Europe, and elsewhere. Our group specialises in addressing acoustics and vibration cases, including acoustic design and testing. But my focus in particular is on vibration-related projects, such as machine dynamics, testing, assessing vibration intrusion into people's homes, and predicting vibration transmission through the ground, like this. But I think in general, in vibration, I think when many of us hear the word vibration, we tend to think of like big engineering structures, like the Millennium Bridge, which famously experienced a particular pedestrian vibration problem a few years ago, if you're aware of that. Or you might think of things like large towers, which are flexing in the wind, and many other different sort of structures. But it's important to remember that vibration also has a very real human factor. So let's introduce HAVS a little with a very simple example. So if you've ever used like an electric drill at home for whatever purpose, like putting up shelves or fixing something like the IKEA, Billy bookshelf to your wall, you will know that using a hand drill causes a vibration sensation through the arm. And if you're a bit too keen on DIY, after a while, you may feel even more uncomfortable sensations through the arm. Well, this is what HAVS is, hand-arm vibration syndrome. And it basically depends on two simple aspects. So firstly, it's the length of time you are holding the drill and pressing that button. And that is basically the same as what is called as exposure time to hand-arm vibration. And secondly, if you are fortunate enough to have an impact hammer option, like I do on my drill, then you will almost certainly feel the sense of magnitude or strength of the vibration. So there's two aspects really, is time and magnitude. So what is HAVS then? So I want to talk to you about hand-arm vibration syndrome, or HAVS for short, but in the employer-employee setting. And it's not the home setting, I'd like to add. So it's just the employer-employee setting. I'll cover what it is, why it matters, how we measure and regulate it, and touch on some of the ongoing research and challenges which are faced in the area of HAVS. So let's start at the very beginning. So what exactly is HAVS now? Well, it is a serious but entirely preventable occupational disease. And that's important. It's an occupational disease. And it's caused by regular and frequent exposure to hand-arm vibration, which usually comes from handheld power tools. And over time, this exposure can lead to actually permanent damage to the blood vessels and muscle skeleton structures in the hand and the arm. Um, and by the way, HAVS was first identified in the mid-1830s when power drills were first introduced in the industrial age by French mining companies. So that's a long time ago. But however, it was not officially recognized as a disease until 150 years later. So that's in the 1980s, when it became known as vibration white finger and carpal tunnel syndrome. So we'll learn about those two things a little bit later. So back to today, according to the Health and Safety Executive in the UK, the HSE, there were 215 new cases of HAVS reported 2 years ago. That's based on data, or the latest data from the Industrial Injuries Database. And in the same year, there are 115 cases of what is called carpal tunnel syndrome in the same year. That's also reported in the IIDB. However, there were many more than this in the pre-2000s, so that was the pre-regulations era. Now, let's start by just looking at a few tools that have shaped our understanding of HAVS. So some of the most common culprits include things like, it won't come as any surprise, those things like using, rock drills in mines, or grinders like here on railway tracks. Of course, you might have guessed that. Chainsaws, using chainsaws, and even hedge cutters. And we'll come back to these 4 examples a little bit later. But these are, regular tools that many people use in construction, forestry, landscaping, and a lot of types of industries on a daily basis. And the risk comes not just from the intensity of the vibration while the tool is being used, but from repeated long-term exposure. And that's important. So sometimes over years or even decades. So it's important to say here that it's not possible also to judge whether one person will suffer from HAVS and another person will not, even if they're using the same machine or very similar machines to each other. So that's one of the difficulties with HAVS. But apart from people who already suffer from conditions like Raynaud syndrome, which we'll look at a little bit, the effects of vibration exposure cannot be predicted. So what does HAVS look like in practice? Well, the symptoms can be quite varied, but they generally fall into 2 main categories. First, there's the vascular symptoms. This is where you get things like finger blanching, often called, vibration white finger. These symptoms can come and go, and they're often triggered by cold or damp conditions. So if you're like me, you may have used a drill or a saw or something outside in winter, and you can see it's more pronounced. Is this you might get something like this vibration white finger, so it becomes actually more difficult to use the equipment, and because of the cold and the damp conditions. And the second condition, the sensory symptoms, this is where people experience numbness, tingling, and a loss of dexterity. And this is carpal tunnel syndrome, and that is the name of the median nerve in the wrist, which gets compressed. And these feelings of numbness, tingling, and weakness are likened to repetitive strain injury, or RSI, and they also present themselves more acutely at nighttime. But vibration white finger and CTS, carpal tunnel syndrome, are the main symptoms and the most well known. So generally, all the effects have a profound and long-term impact. And it's not just about, the ability to do your work after being affected. It's actually about the quality of life, and that's where it is sort of a stronger effect. I mean, simple everyday tasks like can become quite difficult and impossible. So people might find it difficult to do up their buttons on their shirt, hold a knife and fork, or even play a musical instrument. The sort of things we like to do or wish we could do, for that matter. So it is quite a serious disease. So how does the industry work against manual workers coming to harm from vibration exposure? Well, you probably guessed it. The primary mechanism is through health and safety legislation. So regulation is enforced by requiring employers to, 1, assess and manage the risks of vibration exposure. 2, set the exposure limits. And 3, where necessary, implement control measures. And because this is a regulation, a failure to comply can result in significant penalties. And we'll see just a few examples of these cases later. So the regulatory approach is governed by the Control of Vibration at Work regulations in 2005. That's for the UK, and that's used in many other countries around Europe. And within that fairly short document, there are 4 important sections to take note. So it starts at section 5. So here, this says that the employers must assess the risk of employees from exposure to vibration, and that's both hand, arm, and whole body, but we will focus on hand, arm. So that's really about risk assessments. Well, this includes identifying where there is a risk, evaluating the level of risk, the type of exposure, the duration of it, and you also should consider the risk of combined effects of exposure to vibration. The second one, this is another important one. Let's see, if the risk assessment shows that employees are exposed to vibration, and we'll look at a little bit about that a little bit later. So they're exposed to vibration at or above what's called the exposure action value. That's a bit of a mouthful, so it's called the EAV. Then employers must take steps to eliminate or reduce the vibration exposure to as low a level as is reasonably practicable. So, and the other 2 sections, there's section 7. Now, this is where the employers must provide appropriate health surveillance for employees who are likely to be regularly exposed to vibration at or above that EAV value, or otherwise be at risk of it. But this part is typically involves regular checks for symptoms of vibration-related health effects, keeping health records, and acting on any findings. And the 4th one, section 8, says that the employers must provide their employees with adequate information and training. So there we are. So it's adequate. This is the IIT, information, instruction, and training, and it's about the risks from vibration. For example, how to report symptoms to your line manager. So that is control of vibration at work regs, and that is, the values are based on the ISO 5349 standard, and we'll look at this next. So the 2 go together, the control of vibration at work regs and the ISO 5349. Oh, let's have a look at that. So the ISO 5349 is just a standard on how you measure the vibration exposure. And you can see here, here's a typical measurement. This is a power tool here. It's just the handle. So when you take a measurement, you don't measure on the hand or on the wrist, you measure on the handle, because that gives you an idea of how much the vibration magnitude, which is going into the arm through the hand. So let's just look at a typical measurement here. I think this is from one of my photos. So, so if you're able to see here, this red box here, that is just highlighting this little accelerometer, and that is attached to the handle via this cable tie here. And there's the blue cable to the to your meter. And you'll see here, if you can see, there's 3 directions. There's X, Y, and Z. So it measures the vibration motion in all 3 directions. And the most important one really is this one in the Z direction, which should be pointing up from the hand into the arm. So you can imagine your hand here holding this and your arm going in that direction, okay? So, and this is all written in ISO 5349. So, how is the risk of halves managed? There are 2 key thresholds in the regulations you need to know about. So the first one is called the exposure action value, here, EAV, highlighted, and that is set at 2.5 meters per second squared. So if a worker's daily exposure goes above this value, employers have to take action to reduce the risk. Okay, so, and the second one, the exposure limit value, that's doubled, it's 5 meters per second squared, and this is the important thing. This is the legal maximum of daily exposure at that value there, so 5 meters per second squared. But the calculation for exposure is actually quite straightforward. You see it here, and this is in the standard, and it's called the A8 formula, and that equals, to find these values, the exposure values, it is the vibration magnitude, so that's what you measure here, which is the intensity of the vibration multiplied by, okay, the square root of the actual exposure time divided by 8 hours. So it's both the intensity of the vibration and the amount of time someone is exposed to it are really important. And it's important here to say the actual exposure time, it doesn't mean how long you are holding a piece of equipment, it's how long that piece of equipment is actually in use. So, you know, when you're actually pressing that button. And what is also important here, I'd just like to show, which might show it here, is it? Yes. So on the right-hand side, you'll see what's called a weighted curve for vibration exposure. Now, you might have heard this term, the weighted average, before, and in this context, it refers to how different frequencies of vibration affect the human body, specifically the hand and the arm. So the mechanics of the hand arm is more sensitive between these frequencies, between 5 and about 20. So around here, though this part of your body here is more sensitive to vibration in those frequencies and less sensitive in the higher frequencies. Okay, so the hammer action of my drill is around 4,500 beats per minute. And if you work that out, that's about 90 hertz. That is around here. So, of course, you know, when you're drilling, all frequencies are actually occurring. So it's not just at 90 hertz, they're all, and even the lower frequencies when I'm doing the hammer action are actually more affecting the hand-arm vibration. And it's important to say, well, that in screwdriver mode, the dominant frequency is over here, like 1,000, about 1,000 hertz. So, you know, if you're using the impact option, that will have a stronger effect. So this is quite important, and we'll see a little bit later why. So this curve was, you know, a lot of research went into deriving this curve, and it's been, you know, adopted from the ISO standard. So just to repeat, when we talk about weighted vibration exposure, we're really talking about that. In our measurements, these reflect that some frequencies are much more likely to cause harm, that's important, than other frequencies. Now, now we come to the a movie part of the talk, and I don't want to flaunt my exceptional DIY drilling skills for this demo, so I opted for the next best thing, and that is I'll just demo your friendly milk frother. You know, the one that you can grab for maybe it's just £1 at your IKEA store. It might seem a little bit frivolous what I'm going to show, but actually there is a serious note here. This little gadget perfectly illustrates the difference between two pieces of seemingly identical equipment. So let's hopefully this will work. So here's me ready to grab my first frother. You can see here. Let's have a look. There's the black handle there, and inside there's two AA batteries. It doesn't weigh that much. And there is the arm, and there is the frothing part. Now, there's no coffee involved in this, so it's not such an exciting video. But if I just press play here. There's nothing too enlightening going on there. It's just the frother doing its job. And the second video, this is a different one. It isn't the same frother. See, I've done it so this is supposed to be my left hand. I'm not holding it differently here, but it seems so. But you can see that it's pretty obvious which one is the older model and which is the newer replacement. Okay, and you can clearly see the difference in vibration magnitude between the two. As well as you can see, you saw there, it was sort of shifting. There's a shift in frequency, and also you can see that it was off center. That was also causing like a low frequency effect. So this pretty much underscores the importance of employers regularly maintaining equipment or replacing outdated tools. Even though it only cost £1, so it wasn't such a big burden on our budget. But I won't reveal which one I still prefer for making a good cappuccino today. But anyway, let's move on to evaluation. So it's about evaluating, this exposure action value. Is it 2.5 for the first limit, 2.5 meters per second squared? So to give you a sense of how quickly you can reach the action value, so here are some examples you may recall from the beginning of the presentation. I showed 4 examples of tools, and we'll just have a little look at these. So that A8 equation, you might remember from the previous other slide. There's the A8 equation, and you can rework that equation to calculate the length of time it takes before any of the action values are reached. It is a simple formula, and it allows you to determine how long someone can safely use a tool before hitting those critical exposure thresholds. And this actually gives a really good reality check to the situation. So it is the time to reach the exposure action value, which is from that formula. So the first one is, remember, that's supposed to be in the coal mine here. If you're using a rock drill where the magnitude is been measured at 26 meters per second squared, you will reach that action value in 0.07 hours. And that is just 4 minutes. So what it's saying, that is in some language, that is the 4-minute rock drill. So after 4 minutes, that is it. You are done for the day. Other examples, there's that grinder, and it's been assessed at 9 meters per second squared, and that equates to 0.61 hours, and that is sometimes called the 37-minute grinder. So after 37 minutes, yes, that is it, done for the day. Chainsaws, well, the assessed at 7 meters per second squared, and that relates to 61 minutes, so about an hour. And the final one you might remember is this hedge cutter here. This is a specific case. I haven't taken this from the database. But this specific case, it was measured at 21 meters per second squared. It's not actually this one itself, it's just a representation. But it was measured at 21 meters per second squared as a weighted average. And that gives you after 7 minutes, you should not be using that hedge cutter any longer. So you can see it doesn't take long at all to reach potentially harmful levels of exposure. And employers need to know the actual vibration levels their workers are exposed to on site. I mean, it is important. And it's not just what's measured in the lab or on the specification sheet of the tool. Anyway, manufacturers are focused on making sure their test results are consistent and can be compared across different products and over time. So that's what you see on a spec sheet. So there is a discrepancy, therefore, to be mindful about. There's 2 things there: the manufacturer's levels and also measured levels. As a sort of a footnote, my drill, if you look it up on the database, under its hammer action mode, would reach the action value in 47 minutes. So that's something to be mindful of. So what became clear over the years is that standardized lab tests often underestimate the vibration exposure workers actually experience. And because labs handle control measurements on standard equipment, one of their important goals is reproducibility of their tests. So what that means is that the same equipment, if you test it in another lab, in another country, it would produce the same result. So, and also, what is important for the manufacturers is that this data can be compared across, different products in the same range, And you can see how that changes within the scope in that range and also with time. So for example, a tool might be rated at 15 meters per second squared as a weighted average. And that is done in the lab. And that there is an ISO standard for that. There it is, ISO 28927. So that's 15 meters per second squared. But when it's used on site, like here, this is just for example, the magnitude might be 30 meters per second squared. Or actually, it could happen the other way around as well, where it's 15 meters per second, 30 here, and then you measure it at 15. But this kind of variability highlights why it's so important to keep gathering and actually using real world data, so that risk assessments and safety decisions are based on what's actually happening on site. It's not just on idealized test conditions. So what has been done to handle that is the scientists at Health and Safety Executive in Buxton in Derbyshire, in the UK. They've developed practical sheets like this halves calculator, and it lets you actually here. It lets you select a power tool from a drop-down menu here. So it's drop-down menus, and it automatically fills in. You see in yellow here. Fills in the vibration magnitude based on the statistics of all their measured data. And this helps you, if you write in here your duration, it'll help you work out your daily exposure, so your EAV, which is that A8 formula. So here you might see that what I've tried to do is match these up with the previous slide here. So these are automatically filled in. And you also have the capability of putting your own little machine in anyway, and you can reach your time to reach EAV or ELV, and so on. And it is a very useful sheet. It's written in Excel, and it's easy to download, and it's fairly easy to use. And the data in there is, well, they spent many years establishing these values for these ranges here and doing the statistics on them. So let's just have a quick look at a couple of cases here. This is what became case law recently. Then this example for British Coal, where they were found to be aware of the risks posed by hand-arm vibration to miners. Well, it was as early as the 1950s when it was first highlighted. But British Coal, they didn't act quickly enough. As you can see, as late as I think it was 1997, 7 ex-coal miners were awarded a total, that's not each, a total of 125,000, with their individual rewards being 5 to 40,000. So this case really highlights the importance of being proactive about risk management and the potential consequences of failing to protect their workers. And a more recent issue is a more recent case is on the right-hand side here. And it's an interesting case where fines about over £100,000 were issued, where workers were using non-specialized tools, but over long periods. So, over 5 years here, and I say non-specialized, like lawn mowers, the leaf blowers, trimmers, and those hedge cutters, which we saw earlier. So it can affect all different types of work. So there's 2 cases. What are the challenges in the future? Well, there is a big challenge, and that is that for most cases of hand-arm vibration syndrome, there is unfortunately no treatment, and that makes prevention even more critical. So eliminating exposure at an early stage, especially for young people, it can significantly improve their outcomes. So for nerve-related symptoms, which is CTS, which is loss of touch and dexterity and grip, often have no treatment. And circulation-related issues, such as the white fingers and chilblains, with swelling and general pain in your hand, may seem long-term improvement for younger individuals also, if exposure is removed early. There we are. But one thing you can do is, especially for the winter months, is keep your hands warm. That is crucial, as working in cold environments increases the chance of developing HAVS. And finally, I think it's important to highlight here the what they call the HSE's hierarchy of controls. So the first set is for controlling the vibration. It's elimination, substitution, and engineering controls. So you either eliminate that type of work, you either substitute the equipment for new equipment or replacing it, and using engineering controls. So that could actually controlling the vibration magnitude in some way. The next is management controls. So that is assessing how long someone is using a machine, just for example, and then reducing the amount of time they spend. And the final one, personal protection, we'll look at that in a minute, is lower down on the priority. So on that topic of PPE, here are examples of typical anti-vibration gloves which are currently on the market. And you can see here they're typically much thicker than the usual gloves that you use for work or whatever. And they look quite thick. So it looks like, they should be pretty useful or pretty efficient in reducing the effects of vibration. But on the right-hand side, here I've drawn two curves here. The black one, if you remember, comes from the sensitivity, which comes from the 5349 standard. And here is, so for a typical glove, like anti-vibration glove, if you're wearing this, the sensitivity reduces about this amount. But this is this is just from a research article. But what it's saying is that in this area, which is the most significantly effective, is between 5 and say 20 hertz. You see the reduction is only slight here, and you see reductions at the higher frequencies. So there's only minor performance of anti-vibration gloves in those frequencies, but they work well beyond that sensitive zone. There's even examples of where these gloves can amplify at low frequencies. So it would, the sensitivity curve would go up a bit here, which isn't great. But the one positive thing that the gloves do keep the hands warm. So you should use them in winter. So to wrap up, HAVS is a preventable occupational disease. And we've seen that Control of Vibration at Work, REGS 2005, require employers to assess and control vibration exposure. So that's a good thing. However, we should be aware of relying on PPE, such as anti-vibration gloves, as a primary solution. So PPE like this should be a last resort and is often less effective than, say, other things like engineering controls. So looking to the future, there are areas of concern with higher frequency vibration exposures, particularly in fields like dentistry, with those drills, with orthopedic surgeons, and also even with gardening as well. So these are now being recognized as areas of risk. And also two other areas which are prevalence and latency. So prevalence, what is the proportion of workers using a certain tool? What's the proportion of them having halves? Because remember at the beginning I said that some people are more sensitive to halves than others. And also latency, how long between exposure to vibration and having symptoms. So how long does it take? So two areas of research, and they're helping to understand the long-term effect of vibration. And finally, it's just important to note that there's another standard which goes with 5349. It's the 18570, and that is it's a supplementary method for assessing the risk of vibration white finger, and it concerns only VWF cases. So yes, that really wraps up my introduction to halves, and I'm open to any questions. And now I'll just click to the next one. So while you're thinking of things, I can just advertise the next webinar in this personal injury series, which will be presented by our colleague Adam Barrow in a couple of weeks' time. And he will be discussing the development of pedestrian protection measures in vehicle design. And if you haven't already, you can register for this via the Hawkins website. I'll just move on to this slide.
Lovely. Thank you, Andrew. If we could just go through, we did have a pre-submitted question, if we could go through that now. So is what reasonable steps should an employer take to enforce limits on vibration exposure? And they followed this up by saying, we often hear of health and safety training and risk assessments being perceived as a tick box exercise, and that limits imposed do not reflect what happens in practice on a work site. How should the reasonable employer combat the perceived time pressure to complete jobs being more important than observing safe limits when it comes to vibration?
Okay. Yeah, I would say that is really like a management control aspect. And it's not really for me to say how the employer should handle that, really. But what I can say is that in many cases, when a worker has raised a concern about exposure and how long they've been working on a tool, they do tend to overestimate the amount of time they've been using a certain tool, because if you ask them if they're using a tool for grinding, they just say, oh, I've been doing it for the last 5 hours. They haven't taken into account that actually it's not been there 5 hours. They've been actually at work. It's how long that you press the button. So it's important to gather information about how long the equipment is being in use, rather than just managing or just having an estimate of how much time is supposedly used on a job. Okay.
Lovely, thank you. I'm
Thank
just checking the chat now. We'll just give it a little bit longer to see if anything else comes through. In the meantime, if anyone does have any questions or thinks of anything after the webinar, then please feel free to reach out to Andrew or Hawkins directly, and we'd be happy to try and help you. We've just got one question or a couple coming through now. So Andrew, can prolonged use of manual tools, e.g. hammers, cause halves?
Prolonged. Well, the sort of the evidence is the prolonged use. Yeah, it depends on the question. Can it cause halves? It depends upon the person. But the evidence suggests that prolonged use increases the risk of having halves. So it's not a question of whether you will definitely, get halves or not, but it increases the risk, definitely.
Thank you. I think we'll have one more question and then we'll wrap it up. So, how do you differentiate between the symptoms of halves and Raynaud's? I believe that is, as in some cases, as in some cases, IP will claim halves, but medical records could indicate Raynaud's.
Yes, exactly. I mean, it's important to know. Yeah, it's difficult in cases to know what symptoms the claimant has before their claim, really, because the symptoms are very similar, and some people even call this vibration white finger as Raynaud's syndrome. So I think medically it's difficult to distinguish between what is somehow naturally occurring Raynaud's and what is caused by the machine by using a piece of equipment. Yeah, there's nothing really I can really add to that, but it's important to keep medical records.
Lovely, thank you. All right, Andrew, thank you very much. I think we'll wrap it up there. Thank you again to everyone for joining. A recording of the webinar will be available later today. And again, if you do think of anything else or have any other questions, then please feel free to reach out to Andrew directly or someone at Hawkins. But thank you very much, and we'll see you at the next one.
Thank you. Yeah, thank you, Felix.
Thank you.